In this video, we're going to look at how to simplify some trig expressions. So what we want to do is take the expression that we're given and try to simplify that into less terms if possible, or just make the expression overall look simpler than what it is now. And to do that, you're going to need to use your trig identities that we've covered so far. So make sure that somewhere handy you have your reciprocal, quotient, Pythagorean, cofunction, and even odd identities. Hopefully by this point you have them memorized. You're going to need to have them memorized if you don't already. All right, so if we look at the first one, we have cosine squared x, sine x, minus sine x. Okay, and so what we want to do is simplify that. Now, some people's first instinct would be to cancel this sine x with this sine x, but you can't do that because this sine x is part of a larger term, and we can't cancel something in one term and then leave the other part of the term hanging. Another way to think of this and to understand why you can't do that is to think of your sine and cosine as variables. Let's let cosine be x and sine be y. It would be written like this: x squared y minus y would be what you have. And you can't just cancel those y's. What we can do, though, if you were looking at this expression and you wanted to simplify that sum, you may notice that both terms have a y in common, which is like a greatest common factor, and you could pull that out. So if we go back to our trig expression, the trig that represents the y over here is the sine. So we can pull a sine x out, and then what we would have left over in this term is cosine squared x. And then we need something to go here as well, because you remember, you got to think of this as if I take what I pulled out and multiplied it by what's in parentheses, I should get what I started with. So sine times cosine squared gives me cosine squared sine. Sine times what is going to give me this negative sign up here. So I need a negative 1 there. Okay, so far we've pulled out a GCF. And sometimes out to the side, you may want to write down what you did so that when you go back and look at these to study them, you'll know how you got from step 1 to step 2. So we pulled out a GCF. Okay, now anytime you're looking at your problem, if you can automatically see a trig identity, it's a good idea to try to use that. So if I'm looking at this cosine squared x minus 1, and I look over here at my Pythagorean identities, the first one, that was sine squared plus cosine squared equals 1. Remember, that could be written as cosine squared equals 1 minus sine squared. If we manipulate that just a little bit, we can turn it into cosine squared x minus 1. Okay, if we take this one right here, and we take this 1 and subtract it over to this side with the cosine squared, what would we have left on the right? We would have negative sine squared theta left. Okay, so we're basically taking this 1 and subtracting it to this side so that it equals what we need right here. And if we did that, we're left with negative sine squared. So we can replace everything in parentheses here with negative sine squared x. And when you're doing these problems, sometimes your problems will have x's after the trig. Sometimes they'll have thetas. They could have any variable there. So don't let that throw you off. All right, so now what I have is sine x times negative sine squared x. So let's go ahead and multiply those. Well, when you multiply things, you add their exponents. So this is a sine x to the first power, and this is a sine x to the second power. So if we add those, we're going to get a sine to the third power, and then don't forget that you have a negative here. So this is negative sine cubed x. And so that is our simplified version of that trig expression. Okay, let's look at the second one. Okay, in the second one we have sine x plus cotan x cosine x. Okay, when you have an expression that has some sines and cosines in it, a good rule of thumb is to try to rewrite everything in that expression with sines and cosines if possible. because tangent and cotangent and secant and cosecant can all be written in terms of sines and cosines. So if we can take our expression and just try to use strictly sines and cosines, typically there's something that'll cancel out or something that'll simplify for us. The ones that are already sine and cosine, we're going to leave the way they are, but we are going to change this cotangent. Okay, so let's do that. If we're trying to change the cotangent so that everything is in sines and cosines, if we look right here at our cotangent quotient identity, cotan is cosine over sine. So we can put cosine x over sine x in place of the cotan. And if you want to put it in parentheses to kind of keep it separate, you can. So out to the side, I'm just going to put that we used a quotient identity there. So if you go back and look at this, you know what you did, quotient identity. Okay, at this point, I don't see anything that cancels or reduces, but I do see that I have a term over here that is not a fraction, and I have a term over here that does contain a fraction, and I need to add those terms. And you know that when you add fractions, you have to have a common denominator. So that's what I would do here, is I would try to get a common denominator. What you may want to do is simplify this a little bit first so that it looks better. Let me do that first. When you multiply two things, remember you multiply top times top, bottom times bottom. If you want to, you can imagine that under this cosine you have a 1. So cosine times cosine is cosine squared. And then sine times 1 is just sine. Okay, so far this is what we have. All right, if we're going to get a common denominator, that means we want to make both denominators the same thing. So we're going to change what we have a little bit. Remember, there's an understood 1 under that sign. So if you look at your two denominators, your common denominator would be sine of x. Basically, when you're finding a common denominator, you have to have 1 of each thing that's in your denominators. And this 1 doesn't really count. So just sine x in the bottom. Okay, when you adjust a denominator, you have to adjust the numerator accordingly. So my denominator went from a 1 to a sine. Think about it as, what do I need to multiply 1 by so that I get sine, which would be another sine. So this sine up here gets multiplied by a sine. And so that's going to become sine squared. Okay, for this fraction, our denominator didn't change. Our denominator was already sine x, and it stayed sine x. So that means my numerator doesn't have to change either. So it's going to stay cosine squared x. Okay, so there's what we have so far. So you may want to make a note that we found a common denominator here. Okay, hopefully when you see that numerator, you notice that that's a trig identity. If you come over here to your Pythagorean identities, sine squared plus cosine squared equals 1, and that's what we have here, sine squared plus cosine squared. So my whole numerator can become a 1. Okay, so I'm going to put that we used a Pythagorean identity here to get to where we're at. And then 1 over sine will simplify even further. If you look at your reciprocal identities, anytime you have 1 over something, you want to look towards your reciprocal identities. 1 over sine, right here, is cosecant. So this simplifies to cosecant x, and that's using a reciprocal identity. And from there, we can't simplify any further, so that's our simplified answer. I'm going to go back up to this example really quick because we forgot to write down what we did. We took a GCF out, and then right here to get from this set of parentheses to this, remember we used a Pythagorean identity. And then to get from there to here, we just multiplied. It helps to write your steps out so that when you go back, you can see what you did to get from one step to the other. Also, we're working towards doing trig proofs where we have to verify trig identities, and when we do those, you're required to write some sort of justification down for each step. So if you get in the habit of doing it now, it'll come more second nature to you then.